Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on August 12, 2025, so just yesterday. This paper reveals that for certain problems, a new unsupervised training method can boost performance by a remarkable average of 24.7% on the Countdown dataset. The paper is titled, Time is a Feature, Exploiting Temporal Dynamics in Diffusion Language Models. And as we'll see later, the results on other math benchmarks are also really impressive. The core idea is that diffusion language models often find the correct answer partway through their generation process, but then overwrite it, so the authors introduced two methods to fix this. Also, the authors shared their implementation on GitHub, and if you check it out, you'll find the source code for their two main methods. They've included the Temporal Self-Consistency Voting strategy and the code for Temporal Consistency Reinforcement, so you can experiment with these ideas yourself. And this figure really visualizes that core problem, which the authors call temporal oscillation. The bar charts on the left compare the model's final accuracy against its ever pass rate, which is whether it ever found the right answer during the generation process. Across all these benchmarks, you can see a significant gap where correct answers are lost. Then, the diagram on the right shows a concrete example. The model finds the correct answer, 25, midway through, only to change it to an incorrect answer, 2, by the very end. Drilling down a bit more, these plots show how accuracy evolves during the generation process. The chart on the left tracks the final accuracy across 64 sampling steps, and you can see how performance on simpler datasets starts higher, while harder ones climb steadily from a lower base. Now, the two plots on the right really highlight the main issue. They show that persistent gap, the green shaded area, between the final accuracy in orange and the ever pass rate in blue, which represents all the correct answers that are lost along the way. So, to address that problem of lost answers, this table details the results of their first method, temporal majority voting. It compares the baseline model against 3 voting strategies across 4 different math benchmarks. And looking closer, the exponential weighting strategy consistently delivers the best results, shown by the bold numbers and the green improvements over the baseline. For example, on the Countdown dataset, this approach boosts performance by up to 4.7%. Closing some of that gap to the ever pass rate. Alright, moving to their second method, this table shows the results of what they call Temporal Consistency Reinforcement. This is a post-training technique that uses a new metric, temporal semantic entropy, which measures how stable the model's answers are over time. And the results are really striking. Just using their consistency metric as a reward signal, without any ground truth answers, boosts performance dramatically. On the Countdown dataset, for example, it improves accuracy by over 33%. When combined with a standard accuracy reward, the gains are even larger. So in conclusion, the authors show that by paying attention to the entire generation process, instead of just the final answer, they can achieve huge gains. Identifying and fixing this temporal oscillation problem unlocks a lot of hidden potential in these diffusion models. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.